Okay, by popular demand, I'm going to work out numbers 25 and 27 from section 3.8. They were pretty tricky, so hopefully this makes sense to you, and I think I'm going to give you another example of this in the next assignment so you can practice. Okay, so 25 starts off with this function y equals e dx over 10, and in part A they say to find the differential dy. So to do that, you just go dy, make the y into dy, and you just take the derivative. So derivative of e dx over 10 is e dx over 10 times the derivative of x over 10, the chain rule, which is just 1/10, so times 1/10, and then you just put a dx at the end. So basically, dy dx is the derivative. So dy is just the derivative times dx. You just take the derivative and put a dx in it, and that's it. That's what dy is. So we could simplify that, of course, and say, okay, dy is 1/10 e to the x over 10 dx. And what this means is a little bit of how does this, basically you're wondering how does e to the x over 10 change? And it changes by a little bit of y is the derivative, because this thing here is the derivative, which is the slope, right? The derivative is the slope. So a little bit of y is the slope times a little bit of x. So it's basically saying, okay, if this was a straight line, if we want to know of a little tiny bit of change, it's the derivative times a little tiny bit of change in x times the derivative tells you how much y changes. So it's a way to get a little tiny bit of change in y if we have a little tiny bit of change in x. It only works if it's really small change, that's the dy and the dx, because this assumes it's a straight line. dy is the slope times dx. That's assuming a straight line. Of course, it isn't a straight line. So it only works if it's really small. But that's the whole idea of differentials. They're little tiny things. Change this y a little bit, or change x a little bit, how much does y change? And it works if it's really small. Okay, then part B says, okay, how much does it actually change? That's the delta y part. If x equals 0 and dx is 0.1. So if we want to know around the point x equals 0 and we change x by a little tiny bit, so dx is 0.1, what is dy? Well, okay, so dy, we have a formula. That's 1/10 e to the x over 10, x is 0, times dx, so times 0.1. E to the 0 is 1. So that's just 1. And 1/10 times 1/10, because that's what 0.1 is 1/100th, or 0.01. So that's what dy is. If we change x by 0.1, we can assume that e to the x over 10 changes by about 0.01. And again, it's about 0.01 because we're assuming it's a straight line, and we know it's not a straight line. So how much does it actually change? Well, that's what delta y is. So how much it actually changes is what is the function at x plus dx minus what was the function at x. So how much does it actually change? Okay, so now, so we have the function with our little bit of x minus what it was before. Okay, so that is our x plus delta x is 0 plus 0.1. So our function that's e to the x is 0 plus 0.1 divided by 10 minus our function at x, which is e. X, remember, is 0. So e to the 0 over 10. Okay, so that's e to the 0.1 over 10, which is to the 0.01, minus e to the 0, which is 1. And if you do that, which I did in a calculator, this is what's e to the 0.01, and I got that it's 1.010050 minus 1. So the answer is just 0.010, and they round it off in the book. The 5 rounds that up to a 1. So that's what they said in the book, 0.0101. Okay, so that's how you do that. Delta y is what it actually changes, and our dy is a really much simpler approximation if we assume it's a straight line. And as long as x doesn't change that much, it's pretty close, right? 0.01 to 0.0101. I mean, those are really close. Okay, so that's the idea. Okay, so let's look at number 27 now. So number 27, and it says that we have a cube and it's 30 centimeters, but maybe you're off by 0.1 centimeters on each side. Okay, so we have our cube. Let's call each side x, right? So the volume is just x cubed, and you measured it, and x is 30 centimeters, but it was hard to measure it perfectly. So, you're good within 0.1 centimeters or 1 millimeter, so you'd say plus or minus 0.1 centimeters. Okay, so now they say, part A, find the maximum error. Like if that's true and you did the worst job, you're always off by 0.1, how far would you be off? That's what they're saying. If you're always off by 0.1, it is really 30.1 and 30.1, 30.1, how far would you be off? That's the maximum error. And then relative error is, okay, relative to the volume, how big is that? And then percent, you just change your relative error to percent. They're the same thing, you just change it to percent. Okay, so what is the maximum error in the volume of the cube? So the volume of the cube, of course, is just length times width times height is x cubed. So how far off are you? Well, that's our dv, which is just take the derivative of x cubed, which is 3x squared, and we multiply it by dx. So again, we're just using this differential idea. A little bit of volume, take the derivative of 3x squared, the derivative is the slope times a little bit of dx. Okay, well, what's that? X was 30, so we have 3 times 30 squared, and dx is how far off the x could be, so that's 0.1. Okay, so that is 30 squared is 900, times 0.1 is 90, times 3 is 270. So, I think I did that right. So let's see, 30 times 30 is 900, times 3, yeah, so 270. So your maximum error would be 270 centimeters cubed would be how far off you could have been in the volume, which sounds like a lot. So then they say, okay, what is the relative error? So the relative error is we take our dV and divide it by the volume. So our dV was 270, and the volume is 30 times 30 times 30. So that's what 270 divided by, let's see, 3 times 3 times 3 is 27 with 3 zeros, so 27,000. And so we divide that, and it looks like that should just be, isn't that just 0.01? 270 divided by 270,000 equals, 270 divided by 27,000 is, 0.01. So you're only 0.01 relative error. That's the relative error. Relative to the volume, well, that's not so bad, right? So that's what the relative error is. And then the percent error, of course, we just multiply that by 100 to find the percent error. So multiply by 100, 2 decimal places, so that would be 1% error. Okay, so that's the way it works. It's really not that hard stuff. It's just hard to understand what they're asking for. But how it works is pretty easy, and it's pretty cool, because that's how it works. And so this is used a lot in physics and measurement and stuff, because it tells you how far off you can be, because you can never measure something perfectly. You're always off by a little bit. So when you measure something and you say the volume is 27,000, well, yeah, that's your best guess, and you're within 1%. You're within 1% of the answer, but you could be at either side. About 270 on either side is all you can really say. So that's what that would mean. So you'd write your answer as well. The volume would be 27,000 centimeters cubed plus or minus 270 centimeters cubed, because you can never measure something perfectly. Okay, hopefully that helps. And again, try doing these things again on your own, making sure they make sense to you, because that's how you learn it. All right.